Hello everyone. Today we will be solving CSIR UGC NET 2019 June physics paper. This is 14th problem out of the 55 problems in the paper. So the 14th problem goes something like this. Two coherent plane electromagnetic wave of wavelength 0.5 micrometer, both have the same amplitude and linear polarization along the z direction, falls on a y equal to 0 plane. Their wave vector k1 and k2 are as shown. If the angle theta is 30 degree, the fringe spacing of the interference pattern produced by the plane is. So let us try to solve this problem. We have a plane which is like this, and something is falling on k1, and this is k2, and this is y, this is x, and this is E1, this is E2. Okay, so here we have E1 equal to E0 cos kxx minus kyy minus omega t, and we can write as E0 cos k sine theta x minus k cos theta y minus omega t. These are quite simple, that's why I'm not explaining. And similarly, we can write E2 as E0 cos minus k sine theta x minus k cos theta y minus omega t. Then the total electric field E will be E1 plus E2, right? Now if you add the two vector, that is this one and this one, and it will be something like E0 cos of something, and here we have another cos term, cos of something, right, which we can rewrite as 2E0 cos of minus k cos theta y minus omega t, and cos of k sine theta x. Now you might wonder how did you get that? So this is basically cos a plus cos b is equal to 2 times cos a plus b by 2, cos a minus b by 2, something like that. Okay, so this is the form. And now the intensity we can calculate as 4 I naught cos square k sine theta x. So let's say we want to calculate for the nth order maxima. For nth order maxima, we have k sine theta x n equal to n pi, right, for nth maxima. And for n plus 1, we have k sine theta x n plus 1 equal to n plus 1 pi. So we can write beta equal to x n plus 1 minus x n, which will be pi by k sine theta, right? Let me draw a line here and I can solve the rest of the part. So we got beta equal to pi by k sine theta, which is the fringe width, right, fringe spacing. Then we can write beta as pi by 2 pi by lambda sine theta, because we know k is 2 pi by lambda. So if we plug in the values, it will be lambda by 2 sine theta, because pi will cancel, and it is lambda by 2 sine of 30 degree. So sine 30 is half, so 2 it get cancelled, equal to lambda. So this is basically the value of lambda itself, which is 0.5 micrometer. So option D is the correct answer. Well, you can solve in some other way if you want to solve it directly. If you already know the formula for fringe spacing, you can basically write lambda d by d, and here d is equal to d, so basically fringe spacing equal to lambda, and it will be 0.5 micrometer. So you can solve this way also, but I would recommend that you practice in a way which is described in this way. So this is the most general way, and you might think that this is a long process, but it is not. If you practice more than 2 or 3 times, you'll automatically know. So if electric field is this, then the resultant intensity will be this. So from this you can calculate easily. So this is how you solve this kind of a problem. So if you like my video, do subscribe to our channel, ring the notification bell, give a like, also do comment. Thanks for watching, and I will see you in my next video.